product of radicals. When I have a binomial, that is just a binomial. I have two terms, just happens to be a radical constant. Distribute just like I would with anything else. Now when I have square root of 3 times x, remember it's not going to be root 3x. That x is a number, it's not a radical. The x is actually going to be a coefficient. X root 3, but the two radicals, that's when, yes, since it's a minus, I will have a negative. Square root of, now is when I can multiply the radicands, square root of 15. We can mix and match coefficients. We can mix and match radicands. We just can't mix and match coefficients and radicands. Well, if I had 4 square root of 3 plus root 2 times square root of 3 minus 5 square root of 2, almost like we just had two binomials, all I would need to do, FOIL. 4 times square root of 3, 4 root 9. Multiply your coefficients, multiply your radicands, just don't mix and match. 4 root 3 times negative, 5 root 2 is a negative, 4 times 5 is 20. Square root of 3 times 2 is 6. Distribute the square root of 2. Square root of 2 times square root of 3 is square root of 6. Square root of 2 times negative 5 root 2 is negative, positive times negative, 5 root 4. Multiply your coefficients, multiply your radicands, just don't mix and match. Well, now we have some like terms and even some simplification we can do because we have 2 root 6's. That can be a minus 19 root 6. And remember, that's because that did have a 1. Minus 20 and plus 1 would give me a minus 19. Take the sign of the bigger number. But look at these other ones. When I have a square root of 9, ends up being 3 times 4 is 12. When I have square root of 4, it ends up being a 2 times negative 5 is negative 10. So as we complete it, ends up being 10 minus 12 is 2 minus 19 root 6. Now, it also would not matter what order you went in. If you went negative square root of 19 root 6 plus 2, you would be totally correct. There is no order of descending power or even being careful with those. Now, one more example I want to show. A product of square root of a plus square root of b times square root of a minus square root of b. Now, this may look familiar from things we did before, but let's FOIL it out and see what happens. Root a times root a is root a squared, which we notice is going to cancel. Root a times negative root b is negative root ab. Root b times root a is positive, because they're both positive. I could say ba, but I'm going to say ab, just put it in alphabetical order. It's a commutative property of multiplication. But notice, even more is going to cancel. If I have root b times negative root b, I get a negative root b squared. Square root cancels out the square. What I'm left with is an a minus a b. And what we have here, what it sure looks an awful lot like is my difference of squares. Remember when I had that x plus 3, x minus 3, and what would happen is the middle term would cancel, and I had 2 squares? Well, I did have the squares, but the difference is now when I have the square roots, those cancel. I end up with a minus b. And what's nice is this completely got rid of my radicals. This is going to be a big resource for me in some problems coming up.